More and more hardware reviews, especially those of CPUs and GPUs, are including information about how much power those parts actually use and how much they draw, and more people are starting to care as well, but does it actually matter? Well, in this video we're going to find out, but first, if you haven't already, consider subscribing for more videos like this one every Monday, Wednesday and Friday. So here's the idea. I've got this £3,000 gaming PC here, which is a Ryzen 3900X and an RTX 2080 Ti, and we're going to go find out how much power it draws while it's idling, while it's gaming, and while you're maybe doing something like video rendering, for example. And then once we've got all those numbers, we can then swap over the graphics card to a 1660 Ti, a much more reasonable mid-range card, and a 3600X, which is a much more reasonable mid-range CPU. So with that said, I'm going to take the system downstairs, take you with me, and let's get testing. Right, we're downstairs and set up ready for some testing. Let's start off with idle power usage, which looks like for the 3900X and a 2080 Ti, we're looking at about 130 watts. Let's fire up a game. This one's going to be COD, or Call of Duty Modern Warfare, a game I've been playing entirely too much of. We're going to be playing it at 4K to stress the GPU, and honestly, if you've got a 2080 Ti, I should hope you're using it or making use of it anyway. We're also going to be running at high settings again, just to stress the GPU, and we're going to go into a custom game with mixed quality or mixed difficulty bots, as that's a good way to get repeatable results. Obviously, if you go into online games, because you can't do, wow, that's a lot of coil wine. Because you can't pick maps in this and you can't necessarily guarantee the same things will happen, custom games are generally an easier way to go about it. Of course, because every time you do anything in COD, you need to re-optimize your shaders, I'm going to cut here, and I'll come back to you when I'm in game. Right, so we're in, like I said, custom game, 4K, high, pretty much everything. In fact, almost maxed out. The only thing that's not turned on here is DirectX ray tracing, because obviously the GTX 1660 won't have that capability at all, so wouldn't exactly be the fairest of tests. Otherwise, we're getting about 80 FPS here, which is kind of impressive, and power usage is looking like 470, 480 watts. Which sounds about right for a 2080 Ti with a 3900X. I would have tested with a higher end CPU, you know, 3950X or even some of the Threadrippers, but sadly I don't have any, so this is the best I've got at the moment. Right, I'm gonna finish this round and then we'll swap over to a bit of productivity stuff. Oh god, okay, that worked. All right, fair. Oh dear, oh yeah. Cool. And when it comes to productivity stuff, a good example of that would be video rendering. So I've got a 10-minute Premiere test clip, which is just MP4 videos that are cut up into a 10-minute sequence and then is being rendered out to H.264 MP4. I'm in Adobe Media Encoder with CUDA acceleration enabled, although honestly Adobe is pretty awful at using the GPUs in most cases anyway, so it's mostly stressing the CPU here. And in terms of power usage, we're looking at a pretty consistent 240 watts, which sounds about right. Obviously, the idle was, what, 130? The 3900X generally draws about 140 watts under full load anyway, so that quick maths adds up. But what about our mid-range system? Well, let's swap in the CPU and GPU and find out. I'm gonna throw a time lapse in here so you can see what's happening, but you don't necessarily have to sit through the 10 minutes of me trying to do it, so back in a sec. So that is the CPU and GPU swapped in, and now that Windows is booted up and settled, especially because when you first boot into Windows, all of those programs that auto start tend to take a bit more power than your standard like idling web browsing usage. So in terms of power, we're looking at about 100 watts here, give or take, obviously depending on your power states and stuff, it can vary. So 100 watts is our idle. Let's jump into COD and then we will see how it compares. Right, so we're back into COD. This is the same settings as before, still 4K, still basically high everything, which is obviously not quite fair for the 1660 Ti, but we gotta keep the test fair, so let's go. In terms of power usage, we're looking at about 235 watts, which is kind of impressive considering we are still getting like 35 FPS at 4K. Out of a 1660 Ti, oh dear. Although 35 FPS, especially at 4K, is not the most fun playing experience, but oh dear, I cannot hit anything. Right, well, I guess I'll finish this round too, and then we'll move on to the productivity, rendering, that kind of thing. No, that didn't work. Right, so we're back in Media Encoder, same test render from the same file, same CUDA acceleration enabled, and we're looking at about 160 watts here, which again kind of adds up. I mean, this is a CPU that normally draws about 80 watts full load, so about 60 watts more than idle generally makes sense here, so yeah, sounds pretty good. What I'm going to do is leave this running to confirm my test results, and then I'm going to go do some Googling and be back upstairs with some kind of analysis of the results and see how much all of this would actually cost you. Right, so after a quick bit of Googling, I found out that the average person, or the average gamer, spends about 7 to 7.5 hours of gaming per week, which honestly sounds like rookie numbers to me. I know that I game more than that generally, but you can't argue with data, so that's what we use. I also found out that the average price per kilowatt here in the UK is 14.37 pence, so that is the number we'll be using for our calculations. Now, starting off with the 3900X and 2080 Ti system, when you are gaming, that will cost you £26.90 per year, assuming you average that 7.5 hours a week per gaming. Now, I should add that that doesn't include monitors or anything else you would need to have on to game, like your router or any networking gear. It's just a rough idea of the actual system itself. Now, assuming you also did about 7 hours a week of work, rendering, that kind of thing, or even if you did more than 7 hours a week, but it wasn't quite as heavy work as video rendering, it generally adds up. So that would cost you somewhere around £13.45 a year. And if you leave it idling, or if you watch YouTube videos, that kind of thing, which especially on this kind of system is basically just idling, that would cost you £7.29 a year. But what about our cheap PC? Well, that uses a lot less power while gaming, and so it would only cost you around £13.17 a year to game on for that same 7.5 hours a week. If you wanted to use it for work, for video editing, rendering, that kind of thing, that would be £8.97 a year, and if you leave it idling, watching YouTube videos, that kind of thing, it'd be £5.60. So the total for the high-end system would be around about £48 a year versus the cheaper system, which would be around about £28 a year. So does power usage actually matter? Well, not massively. See, if you can already afford a £3,000 gaming PC, then the £50 a year or so that it costs to run the thing probably isn't all that damaging, and even for the cheaper system, it's still not a massive chunk of change that'd be leaving your wallet every year, and I would estimate that you probably use more electricity, keeping your fridge open slightly too long than you do on your gaming PC, and so it's probably not a massive deal. I should also mention that if you look at the cost to run it versus the purchase price for either system, but specifically the high-end one, it's around 1.7% a year of the initial purchase price to upkeep it, so that's still pretty small. Now, there are other factors you might want to consider here. Performance is one of them. Of course, the higher end card you go, the more power it will need, but also the more performance you will get. The 1660 Ti was really out of its wheelhouse, out of its comfort zone today, versus the 2080 Ti, which was very comfortable. With that said, there are also temperatures to consider, the longevity of the cards. Obviously, again, the more power you draw, the hotter the card will generally be, or the bigger a cooling solution you'll need to put on it. And also the heat output too. If you don't want a space heater, maybe don't go for a 2080 Ti. So if you want to see more videos like this one every Monday, Wednesday and Friday, do hit that subscribe button with the bell notification icon. If you want to check out the cards and CPUs I've talked about in this video, do take a look at the top links in the description down below. Those will be Amazon affiliate links that will take you to your local Amazon store, where you can see pricing when and where you watch this. You can also check out the rest of the links in the description, from Patreon to merch to Streamlabs OBS. All of those things help me massively, but generally don't cost you anything unless it's Patreon or merch, in which case it does cost you something, but you get some cool rewards like merch. Otherwise, that is pretty much it. Let me know what you thought of the video in the comments down below. If you have any questions, feel free to leave them down there too, and you can check out some more videos over there as well if you want to keep watching. Otherwise, that is pretty much it. Thanks for watching, and we'll see you all in the next video.